Okay, we're going to do a little work on the brake lathe here today. And we'll zoom you out there. There we go. Picked this up a little bit ago. It's an AccuTurn brake lathe for doing rotors and drums. And on this end here we have a 1" by 8" left hand thread for holding everything onto the spindle when you're turning them. We also got to make some cones and stuff. It didn't come with everything. So today's project is to get a start at least on that nut, and then as we go we'll show you what we're doing. Okay, so to make this nut we looked up a bit of stuff here. We got a Machinery's Handbook, 19th edition. Seems to have everything in there that we need, so we made ourselves a few notes. So to start with, we looked over here on the screw charts to get our diameters, because we got to build this one from scratch. Want to make sure we get it so that it fits somewhat right. So looking up on that other page, we come up with we need a hole diameter of 0.8647, and we need a thread depth of basically 30 thousandths. Give us an idea when we're cutting threads what we're going to do. Then we looked up on this chart here under bolts and nuts for the dimensions of the hex. So we come down to the heavy hex nuts and heavy jam nuts because we want something fairly sturdy here, and we come across here on the 1". And as you can see on the nuts here, we got on the notes, we got a picture there that gives us our dimensions for which part we're looking at. So under the G, which is across the corners, which is the biggest diameter we have to have, we need 1.625 down to 1.575 depending on what size wrench we want to use, basically. And across the corners we decided we're going to go with a 1.5" wrench, so we'll go with a 1.5. So across the corners, so we got with the crossed G here, which is the across the corners, and then we got across the flats, which is the F, which is going to be our wrench size, is going to be 1.575, and across the corners is 1.796, and then a length is 1", which should work about right on that shaft there from what we looked at. So now we got to get to work and find some shaft and then start turning her down. Okay, we're ready to start turning a piece of shaft here. This is an old shaft out of a gearbox or something. It's got a keyway in it, but it's about 2 1/4 inches, so we should be able to get the 1 3/4 that we need out of it. We got it somewhat centered up in the forge eye. You can see she's not in the best of shape, but it's pretty good steel, so should make a decent nut. We got her set up here on the old Wilson. And anyways, we'll give her a cut. We'll bring you back when we're cutting away on her. We're going to try some high-speed steel here and see how that does to knock the rust and everything off so we don't beat up our carbides. Okay. We got her cutting there about 30 thousandths. That's the cut. And, cutting her along pretty good. Bring you back when we get her around. Okay, we got the hole bored out 7/8, which is about the size we want. Got a little chamfer on there. Now we've ground up this carbide braze tipped boring bar to a 6-degree angle. We did this for another job a while back. And we got her lined up on the back side of the piece, so it should be indexed correctly. So now what we're going to do is we'll move the carriage over, move this over, and go down till we hit bottom right there. Let's see, we'll get a little marker here, and we'll put a little marker on there like that, and pull this back out. And we'll read the scale upside down here, kind of, sort of. And we got 2 inches. Just about 2 inches to where the threads are going to start cutting. So we need 1.5 inch knot, so that should give us enough room. Now I don't really have anything to cut a recess in there with. So what we're going to do is use a cross slide to bring it to 0 at the start of our cut. After we engage the half nut, we'll have our feed fed in on our compound, and then we'll engage the half nut and crank our carriage out to 0. So we'll actually have a tapered start to the nut, but that'll be okay because we're going to start threading at 2 inches and we're only going to cut 1.5 inches off, so we'll be cutting where the threads should be good. Hope that they are. And see what kind of luck we have here. So we're going to get started. If everything's going decent, then we'll come back and fill them and go from there. So we need to be on 8 threads per inch, which is right below 16 where we were last time. So that works. And this lever all the way to the right, and last time we were all the way to the left for 16, so that should be good. We're on screw. We got our feed in reverse. We just throw the half nuts in here, and we are feeding away from the chuck, which should give us a left hand at 8 threads per inch. And we've got to cut a depth of approximately 30 thousandths. And the most fun of this is we have no way to test it because we don't have a left hand nut and the spindle is on the brake lathe. And I ain't going to bring the brake lathe over here to try to spin it onto that. So if we absolutely have to, we can take it out of the chuck and index it, put it back in, which we probably will do before we're done. Hopefully not totally mess up the threads, but we'll probably have to demonstrate catching an internal thread. All kinds of fun. Okay, we'll do another pass here. What we're going to do, we're starting to get a bit of a thread in there, looks like. So we got that turned in, or turned out I should say. We'll go out. On this one, then we get bottom, back out just a hair, and take our time. Remember, there we go, send that to 0, and let her run out. Like that. We'll run that in. That out for another cut. And that again to the bottom of the hole. One. And let her cut back out again. Making some kind of a thread in there. So go back in. fast with this one. Okay, we got our threads done in our nut here. You can see we got the ends faced and chamfered a bit there. And it threads on, believe it or not, quite well. I guess everybody gets lucky once in a while. Should be able to just slide this little bit of wiggle in there, but definitely should hold everything together. Now we got to put her on the mill and mill 6 flats on her. Could use a shaper, but the mill's quicker, and ain't gonna take all day to do it.